Okay, hi everybody. Welcome to 2.1, which concerns the meaning and properties of fractions, more appropriately known as rational numbers. So, it's definition. So we would say a rational number is any number that can be put in this form, fraction, which is a over b, where a and b are numbers and b is not zero. So in a fraction, so basically, any number that can be written as a fraction is a rational number, sorry. Like for example, the number 3, even though it's a whole number, you can rewrite that as 3 over 1, so technically all the whole numbers are in the rational number group category. Okay, so anyway, in a fraction, A is called the numerator, which is the top number, and then B is called the denominator, which is the one on the bottom. So we have here A over B. This is the numerator. And this here is the denominator. Okay, proper versus improper. So proper fraction is a fraction where the numerator is smaller than the denominator, or less than. If the fraction is greater than or equal to, right? But mostly greater than. It's very obvious if you see that it's greater than. If it's equal, if a numerator is equal to the denominator, well, that's just the number 1. Okay? So if the numerator is greater than the denominator, the fraction is called improper. Okay, so let's look at this. Okay, so proper or improper. Okay, so I'll give you guys a few seconds to write this on your own. Okay, so take a piece of paper if you don't have it already and jot these answers down, and then we will come back in a minute. Okay, so pause the recording. Here we go. And voila. So hopefully you pause the recording and try these. So 3/4 is proper, right? 3 is less than 4. 1/8 is proper. 1 is less than 8. 9/10 is proper. Is a proper fraction. 9 is less than 10. 9/5 would be considered an improper fraction since 9 is greater than 5. And 10 over 10 is also considered an improper fraction because it's equal to. Cool. Alright, so fractions on the number line and pie chart. Okay, so consider this equivalent fractions. What are they? Let's show an example using a number line or pie chart or both. So here we go, pie chart. You guys understand. Okay, so let's say I wanted to draw half of a pie. Okay, so this is half. Right, this shaded part, or let me see if I have a different color. Here we go, I have a blue. So let's say I have half of a pie right here, okay? Now, if I cut that pie further, right, into fourths, the blue part is still half, right? But now, the way that we express this blue fraction is 2 out of 4, right? But wait a minute, isn't that also 1/2? Well, what if we cut it again, this into this way and this way, so now we have 8 pieces. So the blue part hasn't changed, but now 4 of them are shaded, so that's an equivalent fraction. So a way that you can think of equivalent fractions are basically, it's the same value, but they're using different numbers. And then you might question, well, why? How is it that I can do that? How is it that we can have equivalent fractions? And, well, we could see why. We could see that if, you have a pie and if you cut it up, that doesn't mean that there's any less pie. We didn't take any away. We just cut the pie or the pizza or whatever round thing it is that you like, you could think of it, or cake. And then we can see what equivalent fractions are just straight up. However, this kind of leads us to this property of fractions. Okay, so one of them is multiplication property. Okay, so if you have a fraction and we have A, B, and C numbers such that A and B are non-zero, we can multiply the top of the fraction and the bottom of the fraction and get the same equivalent fraction. An equivalent. It won't be exactly the same, but it will be equivalent. So, what's the property? So in our own words, we could say, you guys can think of a different one, but let me just think of one right here off the cuff. So this means that fractions are equivalent, or they have the same value when multiplied, and when you multiply numerator and the denominator by the same number. And I'll show that to you. So suppose you have the number 1/2. Okay, so let's say I wanted to multiply top and bottom by 2. 1 times 2 is 2. 2 times 2 is 4. See, that's the equivalent. And we know from the previous example that these two are equivalent and they're equal. So that's how that is. Another way to kind of prove it to yourself is that if you think about it, 2 over 2 by itself is 1. So you're technically multiplying the 1/2 by 1. Okay, so it's still the same value. It just has different numbers. Okay, so they're equivalent fractions. Okay, so a super fun example. Write an equivalent fraction for 3/4 with denominator 20. So go ahead. So let's go ahead and do that. We have 3/4, and we want to end up with, we're going to multiply this by something, but we want to have the denominator equal to 20. So what do we need to multiply 4 by in order to get that 20? So 4 times what gives me 20? So if you answered 5, you're correct. Okay, so I'm going to multiply the bottom by 5. But if I multiply the bottom by 5 in order to keep the fraction the same, or to find its equivalent, I need to multiply the numerator by 5 as well. So that becomes 3 times 5, which is 15 on the top. Okay, so now we've found an equivalent fraction with denominator 20. Okay, now this one is interesting. Write 3/4 as an equivalent fraction with the denominator 12x. So that's kind of cool. This should be a times symbol. It's the same thing, but just to distinguish from this x. This x means variable, and this x, little x, was times, but now I'm going to start using dot. Okay, so it's not confusing. So basically, same idea. 4 times something will give me 12x. Well, I know that numerically, like 4 times 3 is 12, right? And then the x I can just write there. Okay, but if I multiply the bottom by 3x, I must also multiply the top. Okay, using my rule. So across the bottom, 4 times 3x is 12x. Check. 3 times 3x will give me 9x. So that's the equivalent fraction with the denominator 12x. Okay. Another awesome property. So it works the other way as well. So if you have a fraction, we can divide top and bottom by the same number. So fractions, can be divided as long as they're not 0. Divided. I guess we could say informally top and bottom, but really, we mean numerator and denominator by the same number. Like it's a property, it's like a characteristic that they have, and it's okay, and it maintains the same value. So it's kind of like, let's say, suppose we had 4/8 and I want to reduce it. So what would I do? I would say, okay, well, I can divide the top by 4, and I can divide, and 4 goes evenly into 8. So dividing top and bottom by 4, I get 1/2, so that's half. Okay, so that's one way we can simplify fractions as well. And it'll help us to get fractions into what's called lowest terms. Okay, so here's some that you try. So I'm going to wait 10 seconds, and I want you to pause the video and then try these problems, and then we'll go over them, okay? So ready, set, pause. So, yeah, so here we go. So just simplifying the following fractions. So 24 over 1 it's the same as saying 24, so that's simplified. 24 over 24, again, any number over itself is equivalent to 1. At 48 over 24, you can divide top and bottom by 24, actually, and you get 2 in the top, 1 on the bottom. So that's just 2. And then 72 over 24, you can also divide by 24 top and bottom. 3 on the top, 1 on the bottom, and so your answer is 3. Okay, and that is it. Super fun homework 2.1. Every other odd. If you want some extra practice, go ahead and do all of them. And the secret word is, ready for it? The secret word is gear. Okay, so you can write that in your secret word column for 2.1. The secret word is gear, like as in I don't know, like the gear of a machine. I don't know. Anyways, I will see you guys on the next video.